welcome back. Those of you joining us on the video, this is SAT Math Crash Course Day 1, Part 2. We're coming back from break, and we're continuing with some questions from SAT Practice Test Number 1. And there's a dog joining us. Is there a dog?
Yes.
Okay.
Sorry, she's
You're
awful.
good. You're good. No, you're good. That is cool. I'm not allergic, so it's all right. All right. What was the last question we did? That was number 11, right? Was the last one we did? I think. Yes, number 13. Okay, so this is a little different here. All right, it's not a word problem. But we're going to continue using the same strategies of plugging in values in place of the variables to make this one a lot less terrifying than it looks. Who answered the last one? That was Elizabeth, right? Or Sharon? You did the last one?
Yes.
So we're at Elizabeth. Can you hear me, Elizabeth?
Yes.
Okay, great. And go ahead and read question number 13 for me, please.
If x is greater than 3, which of the following is equivalent?
To that whole math.
To 1 over...
Yeah. That whole thing.
1
okay.
over x plus 2 plus 1 over x plus 3.
Yeah, that giant, terrifying looking thing. Okay. Does anyone know the algebra on this?
Yes, but it would probably take me a while.
Okay. Right. I mean, there's a way to do it. You know, you can find like a common denominator, or like an algebraic common denominator for these here. I think you multiply the bottom equation by x plus 3 over x plus 3, and the fraction on the right by x plus 2 over x plus 2. I mean, even describing it is kind of exhausting. I don't want to do that. Okay. Let's do the strategy. Rule number 1, we're going to plug in values in place of the variables. Okay. And we're going to find out what this expression is when x equals, well, something. And then we're going to take that same value for x, plug it into the answer choices, and find out what matches up. Does that make some sense?
Yes.
Yeah, that general strategy? Okay. So give me a value for x that we're going to plug into the expression in the question. Can you give me a value for x?
Just 4.
4 is perfect. I love it. Why not, like, 17?
Because 4 is the smallest thing that's larger than 3.
Yeah, we want to make it easy, right? And the question says, I love it. The question says x has got to be greater than 3. Okay? Now, here's the deal. On this problem, you could probably plug in, in fact, I'm certain you can plug in like a 0 for x into the question and into the answer choice. Actually, it makes it even easier. But I want you to get in the habit of working within the parameters of the question. I've seen it where it does matter which values you pick. So let's just practice that. Let's roll with it. Let's make x bigger than 3, but nothing crazy big. Let's pick 4, which you did. So that's absolutely perfect. I love it. So when x is 4, what is this scary-looking expression equal when x is 4? Okay, and I'll guide you through this, but let's plug those in and see if we can simplify that expression. Okay? Can you do that on the whiteboard for me, Elizabeth?
Yeah.
Great.
I can't see the problem on the whiteboard. Just a minute.
Press the refresh button. Thank you so much. And if you still can't figure out, it's not a problem. You might be off the hook.
Okay, we'll just have to hope that I don't write like right on top of it. Hold on. Okay.
Do you see it or no? The question?
No.
You don't see the question? Okay, don't worry about it. I'll send it to somebody else.
No.
Oh, you do see it? Okay, yep, there we go.
It's like, yes.
Okay.
Okay. It's way at the bottom of the corner. I don't know what I did.
Okay, that's all right.
Let's see if I cannot move it. Hold on.
Are you on a tablet or on your computer? Yeah?
Sorry, hold on. It's
You're good.
way at the bottom corner, so I can't see the whole thing. Sorry.
Okay. You're good. I tell you what, why don't I'll just pass it to, you can try to figure out where that's at, and I'll pass it to...
I can write it on here. Just tell me if you can see it on there when I write.
Yeah. I got a 1. Yeah. We're good. No? Don't worry about it. Don't worry about it. Carolyn,
it's going out.
Yeah, you're good. Carolyn, why don't you pick this up? We're just plugging in an x in place, 4 in place of x. into the expression. Can you do that for me, Caroline?
Yep.
Caroline.
Okay.
Caroline. Sorry.
Okay.
I have more coffee. Very good. Okay, and I'm totally cool with just like you don't have to write it all out. You know, if it's a simple like operation, you're adding 4 plus 2, just do it, right? And you're saving yourself a step. Does it make sense what she's done here, ladies?
Yes.
No questions so far. Questions? No?
No.
Okay, now.
No.
All right, so look, we got to simplify this. We're going to have to add those two fractions, right? That 1/6 and 1/7, right? Do you know how to add fractions, Caroline? And you can say no if you don't.
I do, but I'm kind of rusty.
Okay, that's right. That's right. Well, let's talk about it right now. We got to find a common denominator, right? When we're adding fractions.
Yes.
Okay. So, do you know how to find a common denominator?
Kind of.
Okay, I'll take that. I'm going to take that as a no. Okay. I'm going to take it as a I knew at one point, but it's been so long I don't remember. That's probably accurate, right?
Yes.
Okay, all right. No problem. Let me teach you a little trick with common denominators real quick. You may not find the lowest common denominator using this method, but you'll find a common denominator. And that's just to multiply the numbers or whatever's in the denominators together. You will find a common denominator. Maybe not the lowest, but a common denominator. Okay? And in this case, actually, it is the lowest common denominator. So what's 6 times 7?
42.
42. It is 42. So 42 is going to be our common denominator. The question is, how do you describe 1/6 with a 42 in the denominator? Can I show you how?
Yes.
Okay.
Yes.
Here's how you do it. We're going to multiply 1/6 by 7 over 7. Okay? What's 7 divided by 7, Caroline?
1.
1. Yeah. So I'm multiplying 1/6 by 1. And what's 1/6 times 1? And if you don't know, that's okay.
1/6?
Yeah, it's 1/6, right? Because anything times 1 is itself. So I'm not changing the value of 1/6 here. I'm just changing the form by multiplying it by 7 over 7. Does that make some sense?
Yes.
Okay. So that's going to be 1 divided by... And then when you multiply fractions, you just multiply across the numerator and multiply across the denominator. So it's 7 times 1, which is 7, and then 7 times 6, which is 42 in the denominator. Okay? Does that make sense so far, what I've done? Yes or no?
Yes. Yes.
Questions? No?
No.
Okay. What am I going to multiply 1/7 by to get a 42 in the denominator? Do you know, Caroline?
6 over 6?
Absolutely. 6 over 6. Right? So what is that fraction right there going to be?
6 over 42.
There you go. That's it. Absolutely. 6 over 42, right? Because again, when we're multiplying fractions, just multiply across the numerator and across the denominator. You get it. Can't do that with adding fractions, right? We wouldn't add 7 plus 6 and add 42 plus 42. I'll talk about adding fractions. Actually, I'll get to that right here in just a moment, because that's the next step, right? We've got to add those fractions, which we can do now that we have a common denominator, right? And when you add fractions with a common denominator, you just add the numerators. You don't worry about the denominator. You leave the denominator as it is, right? Because like 1/2 plus 1/2 is going to be 1, right? It's not going to be 2 over 4, right? You don't add the denominators together. You just add the numerators together when you're adding fractions, okay? So what does this equal? It's going to be 1 over what? Caroline?
13 over 42.
Absolutely. Any questions about that so far, ladies?
No.
We're good? Okay. Is this review for some of you, or do you guys feel pretty comfortable with this arithmetic? I'm just curious.
I feel pretty comfortable.
You feel pretty comfortable? Okay.
Yeah, I'm comfortable with it.
Okay. Yes, again, some students are coming from different backgrounds with different skill sets. So if you need to, this is a sort of thing, like if you're in your SAT prep, especially using these strategies, you got to know your arithmetic. If you're like, oh, I don't remember how to add fractions, just do a quick like Google search, or like YouTube is actually probably perfect. Like how to add fractions, and you'll find a little tutorial, like 3 minutes, no problem. If you need more help, I do offer one-on-one tutoring, I'd be happy to help you. But that's something pretty straightforward. You can figure out with a YouTube video, I think. Okay. Okay, now let's talk about dividing by fractions. This is a fraction review. It's middle school math, but it's you need it for the SAT. How do you divide by fractions? Does anybody know how?
Flip it.
Yeah, you got to flip it, and you multiply by the reciprocal, right? So 1 is being divided by a fraction, 13 over 42. So what you need to do is you need to multiply 1, which is also 1 over 1, same thing. Multiply that by the reciprocal of 13 over 42, which is what?
13.
Yeah, 42 over 13, the reciprocal. It's flipped. And that gives us what? What is...
42 over 13.
Yeah, we're still, right? Anything times 1, right? 1 over 1 is 1. Anything times 1 is itself, so that's 42 over 13. Does that make sense so far? Yes or no?
Yes. Yeah.
Questions about that? Okay.
No.
Again, you've got to know your arithmetic, but if you don't know your arithmetic, you definitely don't know your algebra. I mean, you don't stand a chance on this with the algebra. But if you're pretty comfortable with arithmetic, this is just basic, like, grade school adding and multiplying and dividing fractions. Okay? All right, so when x is 4, the expression equals 42 over 13. Now let's stop for just a minute. Before we calculate anything else, let's apply rule number 2. Let's use some basic logic, because we can eliminate 2 of these answer choices right off the bat. We don't even need to worry about them, because I know they're not going to give me 42 over 13. Caroline, which answer choice can I eliminate right off the bat, just logically? And if you don't know, that's okay. There's much more in this world I don't know than I do know.
I don't know.
You don't know. That is okay. Ladies, what do you think? I think there's 2 that we can definitely eliminate that are not going to give me 42 over 13 when x is 4.
C and D.
C and D are gone. Why can we eliminate C and D right off the bat?
Because they don't have a denominator.
They don't, yeah, they're not fraction. They're not going to give me a fraction when x is 4. There's no way. Do you see that, Caroline? There's no way they're going to give me a fraction. There's going to be some whole number, right? They're not fractions. Yeah. Now, if x were a fraction, okay, maybe I'd get a fraction. But x is a whole. I got a whole number, so I'm like adding and multiplying a whole. I'm going to get a whole number, not fractions. Does that make sense?
Yes.
Okay.
Yep.
So C and D are gone. Don't even need to worry about them. I'm just plugging in. I'm going to plug in 4 for x into A and B. Which one do you think is more likely, Caroline, to be 42 over 13 when x is 4? A or B? And if you don't know, that's totally okay still. Do you have any idea which is more likely to give you 42 over 13 by looking at it?
I really don't.
That is 100% okay, and I mean that. Well, ladies, what do you think?
I think it's B. I would say B.
B looks more likely. Why would you say B is more likely?
Because there's a larger number on top, it'll come up to a larger number.
Yeah, take a look at B. Like, in the numerator, that's going to be probably bigger than the denominator, right? And in A, it's kind of flipped around. Does that make sense, Caroline? Looking at it that way? This is a totally different way of looking at math. Like, I'm guessing, because pretty much every single student I work with is taught in this way. When you see this is the operation you do. Right? Does that sound familiar with your math instruction?
Yes.
Okay, that's generally, and so like, this is like, okay, let's kind of like just look at this kind of logically. And kind of you're estimating things. What's more likely to be a correct answer choice and what's likely to be an incorrect answer choice, just logically. Totally different way of looking at things, okay? We'll practice that. But I think just logically it's likely to be B. So let's plug in a 4 for x into answer choice B. Can I see you do that on the whiteboard, Caroline?
Yep.
All right, let's do it. Okay, you're just squaring that 4 straight away. That's cool. Love it. 5 times 4 is 20. Do you see what she's doing here, ladies?
Yes.
I love what you're doing with doing that one simple step. You're not wasting your time copying something. And what does that give us? $42 over 13. Do we need to worry about answer choice A?
No.
No. Right? In fact, I know what answer choice A is. What does answer choice A equal? Ladies, do you guys know?
13 over 42.
13 over 42, right? Because answer choice B just flipped. Right. So we can confirm it is indeed answer choice B. Any questions about that?
No.
This is the kind of question that very few students across the country, very few, are going to correctly solve on their own. Some are going to get it, 25% at least, because just the chances. But very few are going to solve this. If you can do it, I see these questions like this all the time on SAT practice tests. They're all 100% doable if you know how to do arithmetic. 100%. You're going to get them. Okay? And this is one of the more complicated ones. But it's just middle school arithmetic. Does that make sense? Yes? No? Yeah? Okay, great.
Yes.
All right. Let's go to I don't see the head now. If you're nodding your heads, I can't see that. So let's do some more. I am gonna clear this. That was, what was that, 13? I think that was 13. It's 14. Oh, boy. Oh, fun. Question number 14. Love this one. We are at Sharon. Loud and proud, please.
Okay. That's y equals 12. What is the value of a to the power of x divided by 2 to the power of y?
Yeah. Yeah. Oh, yeah. Anyone solve this one using the algebra? Anyone know the operation?
No.
Yeah, the correct answer is no. And how do I know that? Because I've never taught a student, ever, who knows how to solve this problem, seeing it for the first time. It is an insanely specific algebraic operation. I'm going to show it to you, by the way. But you don't even need to know it. Again, if we're using the strategies that we're using of plugging in values in place of the variables and using basic logic, you don't even know the operation here. This is doable with the strategies following rule 1 and 2. So let's do that. Sharon, give me some values for x and y that we can plug into this expression here, because we're trying to find the value of a to the power of x over 2 to the power of y.
X is 2 and y is 3.
Okay. Now, let's see. I'm not sure we can use those values. Why not, ladies? Why can't I just plug in a 2 and a 3?
They don't equal 12. It doesn't equal 12.
Because that. Right? It's got to, the x and y values have to be such that 3x minus y has to be 12. Does that make sense, Sharon?
Yes.
Again, this is like, that question number 6, the height question all over again. You've got to, well, again, that would work for anything, but you've got to pick the values that work within the parameters of the question. So, give me another set of values that will work such that 3 times x minus y, whatever they are, gives us 12.
X is 5 and y is 2.
X is 5. I think x would have to be 5 and y would be 3. Right?
Oh, yeah, 3.
Because 15 minus 3 would be 12, right?
Yeah, 3. Sorry.
That would work. That would work, 100%. We could do that. I want to pick an even easier set of numbers. There's another set of numbers that would be even easier. It's going to really simplify this problem. That would work. We could do it. Can you think of a smaller set of values for x and y? If you can't, that's okay. But I can think of one. Anyone else?
You could do 4 and 0, right?
4 and 0. Absolutely. Make x equal 4 and make y equal 0. Right? Because 4 times 3 is going to be 12. And then 12 minus 0 would be, 12. Right? Does that make sense, guys?
I actually have a question.
Yes.
So, from my previous experience, I was possible that setting a value equals to 0 would like be like hard to solve, or like in some cases it won't work?
Yeah, I mean, in some cases it works, in some cases it doesn't. In some cases 1 works, in some cases it doesn't. In some cases 2 works, in some cases it doesn't. It varies. It varies. It's going to save us a step here. I'll show you why in just a little bit.
Okay.
But there's nothing. I love plugging in zeros. I love it. Okay. Now, again, is it magic? Is it going to give you the right answer every time? No. But again, if we plug it in, it's like, ooh, I don't know what to do with that. If it doesn't help us eliminate answer choices, plug in something else, right? Again, we got to look at this like an experiment. You know, we're not married to anything here with these values. We're not. These are variables. It can be anything. And if we try one thing and it doesn't work, try another thing. Does that make sense, Sharon?
Yes.
Look at it like an experiment. You know, like that one question with the text messages. If you try a 1 and a 1. And then, by the way, plugging in 1s for everything works for some questions. If you try it there, you still have 3 answer choices left that give you true statements. So try something else. It's not a problem. Yeah? Make sense?
Yes.
Okay, so make that, there's a little mindset shift there where it's like, let's try it and see if it works. You're not going to hurt anything, and you'll probably be able to eliminate some answer choices, even if you don't get the right answer choice necessarily. Okay. All right, so let's plug in 4 for x and a 0 for y. What does this expression equal, Sharon? Let me see you plug those in, see what we get. I love your questions, by the way. I love them so much. I'm so glad you guys are asking good questions. Great questions. Great. So we get 8 to the power of 4 over 2 to the power of 0. Sharon, what is 2 to the power of 0? Some of you might know what that is. Some of you probably not. What is it?
Isn't it 2 clue?
No. Nope. 2 to the power of 1 would be 2.
So it would be 1?
2 to the power of 0 is 1. In fact, anything to the power of 0 is 1. Is that familiar to some of you ladies?
Yes.
Yes.
Elizabeth and Caroline? A lot of students struggle with that. Can I explain why anything to the power of 0 equals 1? Because I remember, like, as a student, I remember the students being like, just when you see anything to the power of 0 it equals 1. And I was like, but why? And they're like, just when you see it, just do it. I'm like, okay, all right. But I get it now, and so I'm going to share it. So, and it's going to apply to this question here. So if you have, let's say you have x to the power of 7 over x to the power of 4. This is the example I always use. What does that equal? Does anybody know what that equals? X to the power of 7 over x to the power of 4? Anybody?
X to the 3?
Yeah, x to the power of 3. And there's a couple ways to look at it. You can see you've got 7 x's in the numerator, 4 in the denominator. Just cancel out the 4. You know. Or there's like this. So 7 x's. Those are all multiplied here. Right? 7 x's in the numerator, 4 in the denominator. Cancel out 1, 2, 3, 4. You're left with 3 x's there, x to the power of 3. Or there's a simple operation. If you've got a like base in x, which you have here, you have a like base in x. Okay? Right? This wouldn't work if it was x to the power of 7 over y to the power of 4. It wouldn't work. It's got to be x and x. Okay? But if you have a like base, you can take the exponent from the denominator, bring it up to the numerator, and subtract it. And you get x to the power of 7 minus 4, which is x to the power of 3. Does that make sense? Does that make sense?
Yes.
Okay, good. I apologize if you hear there's bath time is happening in a couple rooms over. And I've got 4 daughters. God help me. 7 and under. So the bath time just has to happen. Sometimes it happens when I'm tutoring. Anyway. All right. Can you hear that in the background?
No.
No?
Mm-mm,
You guys
no.
are so polite. I really appreciate it. Thank you for lying to me and telling me what I want to hear. That's what good friends do. That's not true. But all right. If you can't, you will. All right. So does that make sense, though, why that's x to the power of 3? Questions about that?
No.
No? Makes sense? Okay. So what would x to the power of 7 over x to the power of 7 be? Let's do the operation, right? Where you've got a like base in x, take the exponent from the denominator, bring it up to the numerator, Subtract it, and what does that give us?
0.
That gives us x to the power of 0. So if you see anything to the power of 0, basically it means it's being divided by itself. Does that make sense?
Yes.
And anything divided by itself is 1. Isn't that cool?
Okay. Yeah.
I wish people taught me that earlier in life. Not like it would have a huge impact, but it's just annoying that I didn't learn that until my 30s. But anyway. But now you know. Okay. So, all right. So let's go back to the question, right? I'm taking a very sort of circuitous route to finding the answer here, but we're going over some important ideas. So 2 to the power of 0 is 1. So this means, what is this? Oh no, I've just erased it. What is this expression equal, Sharon?
1. Wait,
Well,
what do you mean?
8 to the power of 4 over 1, which is what?
8 to the power of 4.
8 to the power of 4, at the very least, right? Whatever that is, I'm not too worried about at the moment. But does it make sense when x is 4 and y is 0, that expression up here equals 8 to the power of 4? Does that make sense?
Yes.
Yes.
Questions about that?
No.
Caroline, are we good?
Nope. Yep, we're good.
Okay, good. Okay, now, Sharon, let's take a look at the answer choices. I want to limit some of these, okay? And let me start off by saying we can eliminate answer choice D, okay? I've never seen a statement like that be a correct answer choice. They're not going to say, we don't give you enough information to solve this. Never. I've never seen that be the case. I wouldn't worry about it. It's a distractor, okay? All right, so we're going to eliminate answer choice D. By the way, a possible answer choice is there's no solution to this system of equations. That's fine. But to say we don't give you enough information, that's just nuts. They're always going to give you enough information. Okay, so don't worry about answer choice D. We can safely eliminate 2 of these answer choices now with absolute certainty. Any idea which answer choice we can eliminate with absolute certainty, Sharon? Give me one we can absolutely eliminate.
8 to the 8 squared.
Yeah, 8, we can eliminate answer choice C. Why is that?
It's too small.
It's too small. Like, A is tempting to eliminate, but like at the 2 to the power of 12 could be 8 to the power of 4, right? Possibly. We don't know for sure. Okay, we're going to talk about it in just a minute. But I know without a doubt that 8 to the power of 4 does not equal 8 to the power of 2. No question about that, right? Because 8 to the power of 2 is 64, right? 8 times 8. And 8 times 8 just doesn't equal 8 times 8 times 8 times 8. There's no way. Does that make sense?
Yes.
Questions?
Yeah.
Are we good?
Good.
C is gone. Gone.
Good.
Okay. What about answer choice B? Sharon. Can we eliminate B?
I still think it's a little bit too small.
B is too small, right? Because even though the exponent is the same, 8 to the power of 4 just can't equal 4 to the power of 4. It's not the same number multiplied by the number of times, right? It's just 8 times 8 times 8 times 8 just can't equal 4 times 4 times 4 times 4. There's no way. Does that make sense?
Yes.
Answer choice B is gone. Process of elimination. Answer choice A. And it is answer choice A. Can I show you why?
Yes.
Okay, great. I don't think anyone is going to say no. No, you can't. I don't want to know why. Okay. We can express 8 in terms of 2, right? 8 is the same as 2 to the power of 3. Yeah?
Mm-hmm.
Does that make sense? So,
Mm-hmm.
questions about that or no? Right? Because
No.
2 to the power of 3 is 2 times 2 times 2, and 2 times 2 is 4 times 2 is 8, so they're equal. Which means 8 to the power of 4 is the same as 2 to the power of 3 to the power of 4. Aha! Right? Does that make sense? Yes or no?
Yes.
Does that make sense whether those are equal?
Yeah.
Yeah. I need that vocal feedback, guys. Thank you so much. I appreciate it. Now you might be like, I know I'm supposed to do something with those. I know I'm supposed to do something. I got to add them and multiply, but I can never remember what it is. Is there something like that going through your heads? Possibly.
Yes.
Yes? I can't keep the rules for exponents straight. I can't. I don't have them memorized. Here's the good news. You don't need to know them. You don't need to memorize them. Focus on the notation. What the notation means, not what the operation is. And what does it mean to raise something to the power of 4? What does that mean? What does that mean to raise something to the power of 4? Ladies?
You multiply them.
By itself 4 times. So 2 to the power of 3 to the power of 4 means 2 to the power of 3 multiplied by itself 4 times. Does that make sense? Yes. Or no? Make sense?
Yep.
Yeah? Okay. Now you're like, what do I do with all those? I don't know. Well, look. How many 2's do we have here? We've got, 2 to the power of 3 is 2 times 2 times 2. Times 2 times 2 times 2. Times 2 times 2 times 2. Times 2 times 2 times 2. How many 2's is that?
12.
2 to the power of 12. Does that make sense why you don't need to memorize the operation if you know what the notation means?
Yes.
And now that we know what the notation means, actually we know what the operation is. Clearly, we got to multiply them. But that is answer choice A. Any questions about that?
Nope.
Are we good?
No.
Okay.
Yes.
Do you stand a shot of getting this one right by plugging the values in place of the variables?
Yes.
Okay. Yeah. Again, you got to know some arithmetic. You got to know a lot about exponents. Yeah, but it's nothing super complicated. Let me show you the operation they're looking for. Okay, and this is sort of the operation you'll find in the answer choices. In the the answer explanations. By the way, the SAT answer explanations are awful. They're so complicated, and I'm glad they're so bad. They're keeping me in business. Actually, they're giving me a job because they're so bad. But let me erase. I'll show you the right operation here. I'm gonna clear some space. Okay, so here's what they're looking for, and this is why you would never get this on your own. So 8 to the power of x over 2 to the power of y. Let's go back to that. What they're looking for you to do, and actually once I show you the operation, you might be able to, it's possible you'll be able to do it. What they want you to do, and they don't tell you, but they should say it outright, they just don't, but what they want you to do is create a like base. Okay? They want you to combine those exponents, x and y, somehow. Okay? You can only do that if you have a like base. So we got to express 8 in terms of 2. Does that make sense?
Yes.
Okay. So let's express 8 in terms of 2. So 8 becomes 2 to the power of 3 to the power of, that's a funky x, to the power of x over 2 to the power of y. Okay? And now we've gotten, the reason I spent all the time going over all sort of the operations is that we're going to need those operations to do it this way. What's 2 to the power of 3 to the power of x? What do we do with those exponents?
2 to the 3x.
2 to the power of 3x. We got to multiply them. All right? Over 2 to the power of y. Does that make sense?
Yes.
Okay, great.
Yep.
Now that we've got a like base, we can take the exponent from the denominator, bring it up to the numerator, subtract it. All right? So that gives us 2 to the power of 3x minus y. Questions so far?
No.
No? Okay. We're very close to solving this problem. Because what's 3x minus y equal?
12.
12. So therefore, that's got to be 2 to the power of 12. Answer choice A. Crazy specific operation. By the way, not too bad looking at it now. Right? Now that we've gone over all the rules and all the operations and everything like that. But it's a super specific operation I would just never expect anybody to be able to figure out. But if you see this for the first time and you're testing values in place of the variables, you got a shot at it. At the very least of eliminating some of the answer choices. And finding the right one. Questions?
Nope.
No? Okay.
Nope.
All right. Both work. Look, I'm down for whatever works. If you like the algebra here and you see one like this in the future, create a like base and combine the exponents, do it. All right? I do. I teach students in my one-on-one tutoring. I teach them both. I always go over both. But I really recommend the overarching strategy of plugging in values in place of variables because, again, you're seeing a problem you're going to see lots of problems you don't know the right operation for. I promise you that. But you stand a shot at getting them if you can create some values in place of the variables. Let's do some more. Whoop. And what is next? I don't know what is next. We're going to find out what is next. That was number 14? Was that 14? Oh, I love this one so much. This is so great. Who was up next? Was that Sharon? Are we at Elizabeth? Elizabeth. Can you hear me, Elizabeth?
Yes.
Okay, can you see this question on the whiteboard? You might need to shift around a
Yes,
little.
I can.
Okay, good. All right, and if your whiteboard's not working, it doesn't matter because we don't need it here. All right, read this question for me, please.
If t is greater than 0 and t squared minus 4 equals 0, what is the value of t?
Stop. Don't do any don't do anything. Certainly any math. Don't do any algebra here. Let's look at this purely logically. Purely logically. Not algebraically. Not in terms of operation, just logically. What is t squared going to have to equal?
Guess
It's going to have
something that's bigger than 4.
t.
But
So it can't be bigger than 4. T squared?
is it 2?
T is going to have to be 2. Right? Because t squared is going to be 4. And that's the answer. The answer is 2. No operation here. Basic logic. The answer is 2. Questions about that?
Wait, I don't get it because it's t is greater than 0.
Yeah, 2 is greater than 0.
But if you're making 2 squared, it's 4. Sorry, it's 4 minus 4, which equals 0.
Yeah, yeah.
But that would make it 0 equals 0, right?
Yeah, which is a true statement. Which is what we want. That's what we want. We want 0 equals 0. We want a true statement. We want the value for t that gives us a true statement for that equation.
Oh, never mind. I'm sorry. I get it.
You got it?
Sorry.
You got it? No problem.
Yeah.
No
I
problem.
get it,
It's a totally different... Again, you're not thinking in terms of operations here. We're just like, okay, what's t going to have to be? And the answer is 2. I mean, if you want to test value, you can try to plug into 0 for t. You know, you get negative 4 equals 0. That's not true. Try plugging in 1 for t. You get 1 minus 4. It's negative 3 doesn't equal 0. That's not... Try 2. 2 squared is 4, so 4 minus 4. Oh, 2 works. Great. No operations necessary. I see students with this problem, and they're like, they see t squared minus 4, and they immediately start like, okay, I'm going to square both sides here, and then they've already messed up the problem. If they just looked at it just logically and tested values, they could get it. Guys, I would say about 8 out of 10 times, maybe closer to 9 out of 10 times, when you see an equation like this one right here, the correct answer is going to be a single-digit integer. Always positive. I can't think of a time when it was negative. It's possible. I can't think of a time. Almost always positive. Generally 5 or under. And you can just plug in values and test them. It's 8 to 9 times out of 10. It works just logically looking at it or just testing values and plugging them in. Does that make sense?
Yes.
And the funny thing about this question, this comes after like question 14 and 15 are tough questions. You know, we just finished 14. 15 is a tricky one too. It's a real specific operation. I'll probably go over that operation in a level 2 course. That's not our goal. Our goal here is like just is developing some strategies going to simplify the test and give you a good score increase in a short period of time. That's kind of the goal of this course. But 14 and 15 are tough problems. And then they throw 16 at you, which is like they're lobbing a beach ball at you. And like students mess this one up because they're thinking in really complicated terms. And it's not. It's just real basic. You don't even have to calculate a thing. Does that make sense?
Yes.
Guys, this is the SAT. It's real basic. It's a basic test disguised as a really complicated one.
Question number 9 reads as follows. I'm going to read the introduction to the question as well. That gives an equation here. At the top, it looks messy. And the question reads, the speed of sound, the speed of a sound wave in air depends on the air temperature. The formula above shows the relation between A, the speed of a sound wave. That's weird, right? Notice they don't get, it should be S, right? Why don't they call it S? They call it A. I don't know. That's what they do. I do sometimes, in fact, actually recommend that students rewrite equations with more logical variables so just, they don't get mixed up. Right? Why is A speed? Anyway. So they've done. Still not a major issue here on this problem, but I do see it on some others where it makes sense to reassign variables. But anyway, so the formula shows the relation between A, the speed of a sound wave in feet per second, and T, the air temperature in degrees Fahrenheit. So T is the air temperature up here. t. And a is going to be the speed of a sound wave. Okay. Question 9 reads, which of the following expresses air temperature, which is not A, that's T, right? This is very, I think it's intentionally confusing. They want you to keep track of the variables here. Which of the following expresses air temperature, T, in terms of the speed of the sound wave, that's A. So it's a really fancy way, I've seen this wording quite a bit. It's a fancy way of saying isolate T. Isolate T. That is, express the air temperature in terms of the other variables and values, right? And then notice, look at the answer choices here, A, B, C, and D. For all those, T is isolated, right? T is by itself on the left-hand side of the equation. So it's a fancy way, again, of saying isolate T, get T alone. There's an algebraic way to do it. I may show you to do that here in just a minute. But let's keep doing what we're doing, which is just turning everything into arithmetic. We're going to simplify this. You are going to get the correct answer if you do this properly. If you know how to do arithmetic, and remember this is the calculator section, so this is going to be even easier. Doing the arithmetic here, you're just going to punch these values into your calculator. So let's do that. To find out what T is, here's what I'm going to do. I'm going to assign a value to T for this equation up here. I'm going to make T, and we're going to keep it simple here, T equal 1. Okay? I'll make T equal 1. And if T equals 1, I know exactly what A is going to be, right? Because A is just going to be 1052 plus 1.08 times T. 1.08 times 1 is just 1.08. So really, the air temperature is just going to be 1053. I don't even use the calculator here. 1053.08, right? Because that's 1052 plus 1.08. Okay, so when T is 1, A is 1053.08. If you want to do the actual math on your calculator, that's totally fine too. You can punch that in and confirm it. I assure you that is correct. My amazing mental math abilities there. I can add 1.08 to anything. Well, to some things. Okay, anyway, getting sidetracked. Okay, so now let's look at the question again. Which of the following expresses the air temperature in terms of the speed of the sound wave? So if I plug in that 1053.8 in for A into the answer choices, right? All of them. The correct answer choice is going to give me a 1 for T, right? So let's do it. Let's plug in that 1053.08 in for A here, and then I'll get, when I do that, I get, well, 1.08 over 1.08, which is 1. So that looks pretty good. In fact, I'm fairly certain answer choice A is correct. Now, here's what we want to do, though. We don't want to stop just when we see something that looks good. We want to be able to confirm the correct answer choice, but also eliminate all the incorrect answer choices, especially when you're using this strategy of plugging in values in place of the variables. It's real important. Depending on the values that you put it, like you plugged in a 0 for T, I believe you'd actually get 2 correct answer choices, in which case you've got to test another value for T in order to eliminate the incorrect answer choice. So just because you see a true statement does not necessarily mean it's the correct answer choice. It's a good sign, but you want to be able to eliminate all the incorrect answer choices as well. So let's do that. I'm going to plug that 1053.08 into the next answer choice. So I had the eraser on there, not the drawing tool. There we go. I'll plug that into the A value for answer choice B, and I know I'm going to get like 2,000 something or other divided by almost 1. It's going to be like in 2,000. There's no way it's B. And this is where also, again, like basic estimation and logic can come into play. I don't even have to worry about calculating. You can punch it in the calculator if you want to, but I'm just looking at it right now. And I can tell you that's not going to equal 1 when I plug that in. Okay, so don't have to worry about that. What about answer choice C? I'm going to plug that into the A value for answer choice C. And I'm looking at that now, and the same thing. I don't need to punch this into the calculator because I got 1052 minus something bigger than 1052. I'm going to get something less than 0. Right? It's going to be negative. So I'm going to get a negative in the numerator and a positive in the denominator. The T value for answer choice C is going to be negative. So there's no way it's going to be 1 because 1 is positive. I don't even have to worry about calculating. You can if you want to. You punch that into the calculator. You can confirm it. But logically, you can also just simply eliminate it. So B and C are gone. Let's plug it into answer choice D, 1053.08. Plug that into the A value in answer choice D, and the same thing here. I don't even have to worry about this. This is like, I've got 1 divided by something bigger than 2,000, and it's just not going to be 1. There's no way. I don't have to worry about it in answer choice. D is gone. So we've done it. We've confirmed A, and we've eliminated the incorrect answer choices. We feel pretty confident about this, solving this problem here. It is answer choice A. I see students mess up the algebra on this all the time. All the time they mess up the algebra. But it's pretty tricky if you know how to add and subtract. It's pretty tricky to mess up the arithmetic here, which I recommend using this strategy. Okay. All right. I'm going to clear the whiteboard here, but question number 10 is sort of a follow-up question. So I'm gonna put question number 9 and 10 back on, or 9 back on, and then also include 10. And I think number 10 is where we left off at on the second half of day 1's class. So we're almost done here. And again, if you have specific questions about a particular problem, feel free to reach out to me, certainly by email. You can send me a text if you'd like to. I think you guys have my cell number. Or you can save it for class, and I'll go over these questions here. All of them. We'll go over them again. But thinking and speaking at the same time. It's an important skill. We'll go over all this in the beginning of the next class, and the other questions of homework that you haven't seen yet. Okay, so let's read question number 10. So question number 10, which is again related to question number 9. There's sort of a question set here. Question number 10 reads, at which of the following air temperatures will the speed of the sound wave be closest to 1,000 feet per second? Okay. Again, there's a way to do this algebraically. I can the speed of the sound wave is A, so I can plug in 1,000 for A and then isolate T. I can do it. It's not super complicated, but man, I've just seen so many kids mess that up, and there's just no there's no reason to complicate this if you can just do this with the arithmetic. So let's do it. Let's test the answer choices here, right? Because these are all these answer choices here, A, B, C, and D. These are all potential values for T. So let's plug these in and see which one gives us the one closest to 1,000 for A, the speed of the sound wave. Okay, so let's test answer choice A here. I'm going to bust out the old iPhone calculator. So I'm going to plug in -46 for T, so that's going to give us 1,052 minus 1.08 times -46. Okay, so I'm going to calculate that. 46 times 1.08 equals... Oh, I lied. Hold on. It's plus. There we go. That makes more sense now. So let me try it again. 1.08 times 46 equals, and I'm going to add that to 1,052, and I get, let me zoom out just a little bit, I'm going to get 1,002.32, which is pretty close to 1,000. Looking pretty good so far, right? But notice all the values here are pretty close to each other here in the answer choices. So let's see if we can get a little bit closer. Okay, so I'm going to take a -48, plug that in to the equation. 1,052 plus 1.08 times -48. So let's see what we get here. Okay, times 48 equals 2, and I get, something a little bit closer. I get 1,000.16. So B is closer so far. I can already eliminate A. I don't have to worry about it. That's a potential answer choice. Let's see if C gets us closer. Okay, so it's 1,052 plus 1.08 times -49 equals 1.08 times -49 equals plus 2 equals, okay, 999.8 0.08. And the question is, which of the following air temperatures will, at which the following air temperatures will the speed of sound wave be closest to 1,000 feet per second? So the question is, what's closer, B or C? What's closer to 1,000? Which of those two? And if you look at it, it's pretty clear, I think, that it's 1,000.16, right? Because that's only
0.16.
away from 1,000. Whereas answer choice C is like 0.92 feet per second. Not a dramatic difference, but clearly answer choice B is closer. I don't even have to worry about D because that's going to be even smaller than 999.08, so we can confirm it. Basic logic come into play then as well. That answer choice B is the correct answer choice here. Okay.
Who did the last one? Was that Elizabeth or Caroline? Or maybe Sharon? I don't recall actually.
I did.
Is that Elizabeth?
Yeah.
Okay, Caroline. Caroline, go ahead and read question number 8 for me, please. Can you see it on the whiteboard?
Okay. Yep.
Okay, great.
For what value of n is n minus 1 plus 1 equal to 0?
Okay, and those are the absolute value bars right there that are sort of surrounding the n minus 1. Those aren't parentheses, right? Absolute value bars. Are you familiar, Caroline, with absolute value or no? And you can say
not
no.
really.
Okay, that is okay. Because it is on the basic concept cheat sheet on the rules for mathing. And it is, let me see, it is basic concept J. Can you guys see that on the screen?
Yes.
Absolute value. Okay. Caroline, go ahead and read the deal with absolute value.
Okay. Calculate what's inside the bars. If it's possible, if it's positive, keep it positive. If it's negative, make it positive.
There you go. Okay, great. And I've got an example here. We got 3 minus 5, the absolute value, of 3 minus 5. And so let's do the operation here, right? It says calculate what's inside the bars. So what's 3 minus 5, Caroline?
-2.
It is -2. Okay, now, if it's positive, keep it positive. But if it's negative, make it positive. So how do we make -2 positive? What does that become? If we're going to magically turn that negative sign into a positive sign, what does -2 become?
+2?
+2. Yes, it is +2, right? And that's right there in the example, right? 3 minus 5. The absolute value of 3 minus 5 does equal 2. Is that familiar to Sharon and Elizabeth? Absolute value?
Yes.
You've seen it before?
Yes.
Okay.
Yes.
If there's a concept you're like, oh, this is testing me on something, I know I should know it, check it out on the rules for mathing. I've got on the basic concept cheat sheet, I've got stuff on statistics, including like mean, median, and mode. I've got stuff on trigonometry and on systems of equations, on graphing, and all this stuff. I'll go over how to use this exactly as a reference toward the end of the course. But just so you know, if you see a concept, sometimes they do test you on some specific concepts. You got to know. Check it out on the rules for mathing. If there is a concept they test you on, it is on the rules for mathing. And I try to break it into really, really brutally simple terms. It's all there. So, do you know what absolute value means now, Caroline?
Yes.
Calculate what's inside the bars and make it positive, okay? So, the question is, what value of n is n minus, the absolute value of n minus 1 plus 1 equal to 0? How can we find the right answer choice here?
I don't think you can.
Well, these are all possible, well, A, B, and C are all possible values for n, right?
Yes.
Okay, so we can plug those into this expression, the absolute value of n minus 1 plus 1, and see which one gives us 0, if any of them give us 0. And I'm not certain any will, but we can test them, all right? So let me see you do that. Let me see you plug in those answer choices in for n, right? And see which ones, or which one, if any, gives us a 0. Make sense?
Yes.
Okay, let me see you do that on the whiteboard. Please.
Oh no, I did something. Oh, okay, never mind, fixed
Was
it.
it? Okay, good. And do you ladies have a couple minutes to go over? Do you mind?
Oh, no, it's fine.
Okay.
Yeah.
All right. If you got to go, you can go if you got other commitments or whatever, but I'd rather finish this problem. Okay. So what is, well, hold on just a minute. What is the absolute value of 0 minus 1? Well, let's do absolute value. Remember, you got to calculate what's inside the bars. What's 0 minus 1, Caroline?
-1?
It is -1. You're right. Your instincts are pretty good, Caroline. You got to learn to trust them. They're pretty good. It is -1, or -1, not 0. So we got the absolute value of -1, right? But what do we do with absolute value? Do you remember? You calculate what's inside the bars, so what you did. If it's positive, keep it positive. If it's negative, make it positive. Yeah, there you go. It's +1. Does that make sense? So we got +1 plus 1. Does that give us 0?
Nope.
9. Neeks. It is not 0. So answer choice A is gone. Let's try it with B. Plug in a 1 for n. And do the same thing. We got 0. Plus 1. And what does that give us?
So it is 1?
What? 0 plus 1? Well, 0 plus 1 is 1. Does that equal 0, right? Because the question is which of those values for n gives us 0?
Oh no. Okay.
Right? It's not equal to 0. Yeah, it's equal to 1, which means it's not equal to 0. So B is gone, right? When we plug in a 1 for n, we don't get 0. Let's try 2. Okay, absolute value of C minus 1. Good. We get 1 plus 1, which is 2. Not 0. C is gone. We've confirmed it. It's answer choice D. Okay. Any questions about that?
Nope.
No? Then I say, look, we don't need to think like theoretically about this. Right? We don't need to be like, if I understand absolute value properly, which by the way, that is a valid way to solve it. Right? If you really understand absolute value, then you should know that this has to be positive, which means that if we add 1 to anything that's positive, or 0, I guess it could be 0, because the absolute value of 0 is 0. There's no way to make that thing, we need this thing to be -1. And that's not going to be -1. It can't be, because its absolute value can't be negative. It could be 0, or anything above it, but it can't be negative. So that's one way to do it, if you just really, really understand that. But again, you can just plug in the values in place of the variables, and you can confirm it with absolute certainty. It is answer choice D. Any questions about that?
Nope.
Nope.
No? Okay. Good. Okay, let's wrap it up there. What I'm going to do, I'm going to send you guys a link, an email, in the coming days, give me a day or two, to upload the videos. And the homework that I want you to do. And what I'm going to have you do for homework, I'm going to have you redo all the problems that we did here in the class. Okay? And I want you to redo them on your own. If you don't know how to solve them on your own, check out the video and find out how to solve it using the strategies I've been teaching you here so far in this class. Following rules number 1 and 2, plugging in values in place of the variables and using basic logic to eliminate answer choices. Okay? So go to the video for reference if you don't know how to solve it. If you know how to solve it on your own, you don't need to reference videos, great. Some of you may not need to check out the videos. Some of you may need to. That's totally cool. Whatever you need to do to solve it using these strategies. There are going to be a couple more questions, like 4 or 5 more questions that you've not seen yet, that I want you to apply the strategies to and practice them on your own. Okay? If you don't know how to solve them on your own using these strategies, don't worry about it, because we're going to go over them at the beginning of the next class. Okay? But I want you to try. And I think it's important that you try. Okay? If you think by taking an 8-hour class, you're going to see a big increase on your SAT score, I'm sorry to disappoint you. It's not going to happen. Okay? You might see an increase. Some of you, some of you might. It's possible. But what's gonna get you, what's much more likely to get the increase is if you practice the things I'm showing you. You've got to practice it. The analogy I use is this is a playbook, but you've got to practice. You got to run the plays on your own, right? This is like the music sheet, but you've got to practice the music to be able to do it on the actual SAT. Does that make sense?
Yes.
Yep.